lot of computer power is required to run a cloud environment, and that can become costly. Virtualization is what made cloud computing possible. When running applications that support lots of clients, a standard model is to separate the different functions of the application into separate servers. In this example, each server is located on a separate server. The customer only has to communicate with the front-end web server. Then the web server communicates with the application server, and then the application server communicates with the database server. Performance and security-wise, this makes sense, because each server has its own computer resources, and access is compartmentalized. However, as servers have become smarter and more efficient, having one physical server just to run one web or application or database server has become very inefficient. This becomes a costly way to underutilize the abilities of the physical server. With virtualization, you can run multiple servers on a single physical server. Each virtual server or virtual machine is a standalone server running on the physical hardware of one server. They act as if they were on separate physical servers though. But how do you make sure they share the resources of the physical server fairly and without conflict with each other? The hypervisor, or virtual machine monitor, helps divide the physical resources of the server to the virtual machines. The hypervisor provides a virtual environment with CPU, memory, and storage to each virtual machine, and each virtual machine acts as if it has direct access to the physical resources with no idea that the hypervisor is in the middle controlling the access. Because each virtual machine is separated, you can run different operating systems or even different versions of the same operating system, all without having to purchase additional servers. There are two different models for implementing hypervisors, Type 1 and Type 2. Type 1 hypervisors are bare metal hypervisors. It runs directly on the server with no middleman, allocating CPU, memory, and storage to each virtual machine as needed. In Linux, two popular Type 1 hypervisor packages used are KVM, kernel-based virtual machine, a standard Linux kernel with special hypervisor module. Depending on the CPU used, it can host any type of operating system once it's installed. And a Zen, which is an open source standard for hardware virtualization, and includes additional software, including an API stack for managing the hypervisor from a guest operating system. Type 2 hypervisors are hosted hypervisors because they run on top of an existing operating system and runs like any other application on the host system. Type 2 runs guest virtual machines as separate processes on the host's operating system. The guest operating systems are still separate, so you can use Linux for the host and still run Windows or Mac OS on the guest, or vice versa. With Type 2, you do not have to create a new server environment. You can run it on an already installed operating system. Some popular Type 2 hypervisors are VMware and VirtualBox. Virtual machines created to run in a hypervisor must be configured to determine the resources they need and how they interact with the hardware. These settings can be saved to template files so that they can be easily duplicated. Open Virtualization Format, OVF, is an open source standard for virtual machine configurations. OVF format creates a distribution package. The package uses a single XML configuration file to define the virtual machine hardware environment requirements. Along with that file, there are other files that define the requirements for network access, drivers, and operating system requirements. OVF templates are hard to distribute. The solution to this are Open Virtualization Appliance, OVA format. OVA bundles all the OVF files into a single tar file for easy distribution. While a virtual machine is a great way to spin up multiple servers in a server environment, they are clunky for working with and distributing applications. The solution to this is containers. Containers gather all the necessary files to run an application: the runtime, library, database, and any operating system files. The container contains everything the application needs to run, allowing the application to be self-sufficient. If you run multiple applications, you can install multiple containers, and each container is still a self-contained environment for each application. By packaging an application as a container, you are ensuring that the application will work for the customer the same way it worked in development. Containers don't contain the entire operating system, which makes them easier to distribute than virtual machines. Probably the most popular container package used in Linux is Docker. Docker is open source, extremely lightweight, and allows several containers to run on the same host Linux system. Docker runs a separate daemon that manages the Docker images. The daemon listens for requests from the individual Docker containers and from the command line interface, allowing you to control the container environments. Docker uses the Docker container image files to store container configurations. This file is a read-only container image that can store and distribute application containers. Review question type. Which type of hypervisor interfaces directly with the host system hardware? The answer is the Type 1 interfaces directly with the system hardware and acts as a middleman controlling resources for virtual machine. Public and private are a method of implementing cloud services and not a hypervisor. Type 2 hypervisor runs on top of a host operating system and does not interface directly with the host system. And hybrid is another method of implementing a cloud service and not a hypervisor. Question 2. What method should you use to easily move an application from a development environment to a production environment without having to duplicate the operating system? The answer is container, because containers contain all the files necessary to run an application regardless of operating system. The keyword in this question was easily move an application. Public and private would not be the answer because they are a method of implementing cloud services and can't guarantee the same operating system. And Type 1 and Type 2 hypervisors would not be an answer because they can't host an application without a virtual machine. Thank you everybody for your patience, and please join me again next time.